Hey, welcome everybody to the Smart Data Collection for Sensor Networks. We'll be presenting the TAPIS framework to you folks today and some of the APIs that can be used to store and process some streaming sensor data. That's very applicable to climate research, and we're actually going to be leveraging these APIs for the Hawaii Mesonet as that gets up and going. So we'll be presenting some of the technologies that we'll be using for you today. With that, and you'll actually get some hands-on with using TAPIS in a training environment. So the other things we're going to introduce you to is a Python library that helps making accessing TAPIS a little easier. So it's called tapipy. So that'll be integrated in the Jupyter notebook that we've set up for you folks today. So hopefully everyone who's attending this has a basic understanding of some Python, as well as some understanding of how to leverage a Jupyter notebook. So we will be using the Mana HPC today for launching our notebook sessions. And so Michael, I think, will be covering how we're going to do that if you haven't done that before. We are also making use of the National Science Foundation's Jetstream virtual cloud infrastructure. So we have a virtual machine set up in that cloud for today's workshop. So it's going to be at this address here. So if you go to the setup, you can get this. So if you want to SSH in, you don't have to SSH into this machine. We're just going to be using it as a storage and a storage system for TAPIS to upload and download files from for part of this workshop. The username will be the one that you grab out of the spreadsheet, and then the password will be training. And also feel free to ask any questions at any time in the presentation. The presenters today are going to be Jared McLean. He's one of the software research engineers that we have in the Information Technology Cyber Infrastructure group. And Michael Dodge, he's one of our undergraduates that's in our group, and he's also one of the EQI students. And then myself, I'm Sean Cleveland. I'm a cyber infrastructure research scientist in Information Technology Services for the University of Hawaii system. So we're very happy that you decided to attend the workshop. So with that, I will get into introducing TAPIS, a little bit of background on that, and some of the capabilities that it has. So if you're interested in following along with the slides, there's a link here in the introduction. I should probably hand this link out. If you want the materials, they are here so that you can follow along. Currently on introduction. All right. Okay. So what is TAPIS? It is a joint effort from the Texas Advanced Computing Center and the University of Hawaii system. It's a grant that we're both on. It's a National Science Foundation funded project. It's open source, and it is a scientific framework to support research. So in general, it's a framework that supports any domain science. It's infrastructure and software and tools that you don't have to build or set up yourself. And the whole idea is to help researchers accelerate their timeline to their analysis, their discoveries, their publications. So it's supposed to help with doing all of those things. More technically, it's a set of APIs that have authentication and authorization services in front of them, databases to persist and record data and provenance, as well as recording all the actions users take related to running compute jobs, moving data around. It's all hosted somewhere else, like the cloud, and it's also maintained by other folks. Currently, there's over 51,000 researchers that have leveraged TAPIS just in the last year. So those are numbers for 2020 to 2021. And both two science gateways that are kind of projects that are with our group that are in Hawaii are the EQI Gateway and the Hawaii Climate Data Portal. They're both built using this technology. So TAPIS essentially has a number of API services that fall into sort of four categories. The first has to do with authentication and security. So everything that you do is authenticated and checked for that there's the right authorizations and roles and things on the different other services and objects that you manipulate in TAPIS. There is metadata and management APIs. So there's a MongoDB service that's we call metadata, and then there's a Postgres service that's called PGREST for being able to store JSON documents and doing database-like things. We have data management and code execution APIs, so being able to register storage systems, which we'll do today, as well as execution systems like our HPC system or other lab computers or things that you're going to execute on clouds, stuff like that. Moving files around, registering software applications and running jobs and managing those jobs. And then finally, the stuff we're going to cover today has to do with some of the streaming data and events functions, as well as actors. So we'll talk a little bit more about that. If you're interested in more, you can go to tapis-project.org to see a little bit more about the framework. So how does Tapis support all those services I just talked about? There's kind of three concepts. There's APIs, REST, and JSON. And so I will cover and define those if you're not familiar. So APIs are application programming interfaces. This basically is just the way that two software applications can be able to talk to one another and exchange information and talk to each other in ways that they can make requests of each other to do certain things. Each API essentially defines what functionalities are available in the piece of software that are going to be exposed. And they're essentially kind of independent of however they're implemented. So you can have an R API that can talk to a Python API. As long as they can speak the API language of one another, then they can talk to one another. Most of the applications that you utilize with your laptops, your workstations, your cell phones, they're all leveraging APIs. So most of the web is powered by application programming interfaces. So REST is representational state transfer. This is not a standard, but it's an architectural style for web applications, and it is the style that we leverage for the Tapis APIs. It was devised by a PhD student, Roy Fieldings, during his dissertation. It makes use of pretty much all the basic web standards. It's pretty ubiquitous in the web right now. Restful systems, basically, you can just think of it characterized by there's a client and then there's a server. So clients make requests to servers, like in this instance below, the client says, please insert this piece of data into, say, you're a database. And the server says, okay, I'll put this in my database. And it responds back with, I inserted that data to the client. So the client has some sort of message they get back that they know something happened. So that's kind of the basic ideas behind REST. You make a request, you get a response. And then finally, we need some way to exchange information between our clients and our APIs here. So we use JSON, which is JavaScript object notation. It's a lightweight data interchange format. It's easy for humans to read. If you use Python quite a bit, you'll notice that JSON kind of looks a lot like a dictionary format, if you will. So anyway, this is what Tapis uses, and this is what we'll use today in some of our work. Whoops, wrong buttons. Okay, digging in a little bit more to some of the stuff that Tapis does. As researchers, you can if you leverage Tapis, you make requests to the Tapis APIs, and then on your behalf, Tapis can talk to HPC systems, high throughput computing, cloud systems to be able to, execute code, move data around, transform data, register applications, and launch all these sorts of things that handle sort of the workflows for you of having to stage that data, stage those software applications, talk to the scheduler, monitor the jobs, and then move everything back. There's also support for complex workflows, so having events trigger processes, having workflows, some parts of workflows called other workflows. So there's sort of support for all of this within Tapis. And then there's a feature here that's called an actor. So this is sort of a function as a service. If you've heard of AWS Lambda, in some ways it's similar to that. The idea is that you essentially define an actor. It's a Docker image that you can pass a message to, and then the code that's inside this Docker image reads the message and executes some sort of function or program, and then spits out some information or does something. And so we'll be using this idea of an actor today with our streaming events triggers that we're going to talk about later. The Streams API is one of these new APIs that we've just implemented in Tapis. This is essentially, the idea is that there are some geographically distributed sites that have some sort of um, instrument that's recording data, and it will send that data to a gateway or directly to Tapis, the Streams API, and then that information is stored and processed in Tapis, and we can set up ways of listening to the data and setting thresholds to execute other workflows like actors, like I talked about, or webhooks. So that's one of the reasons you're registered for Discord, because we're going to use a webhook from Discord as part of this tutorial. So how do researchers use Tapis? Since we're using REST APIs, curl can be a client that we can use to make requests to Tapis. So if you ever use curl, then that's one way we can talk to Tapis APIs. It's rather difficult to remember all that. There's also some command line interfaces that we've built. And then one of the other ways here is the Tapis Python SDK tapipy, which we will actually be using today. And then a way that a lot of researchers access Tapis and the services is through science gateways that are built on top of Tapis. So Cyverse is sort of a domain agnostic gateway that can run a bunch of different software on Stampede 2 resources. Design Safe is one for some geoengineering folks. We have 3 that we use here at the University of Hawaii. So CMyIki is a microbiome science gateway that runs a couple different relatively complicated pipeline workflows for processing bacterial, fungal, and archaeal microbiome sequence data. So we actually get quite a bit of usage out of that from that group. And then the EQY project is one of the projects we built a gateway for. And then the Hawaii Climate Data Portal, which we just rolled out yesterday, also does this. All of these tools are essentially allow third-party folks outside of Tapis to build on top of it, building products. And just one other thing to note, the streaming stuff that we'll be talking about today will actually be leveraging as the Hawaii Mesonet project comes online. So about another 90 climate stations are going to be installed around the state by Tom Jambaluka's group that will be sharing data locally with Hawaii, but also nationally into this MADIS database. So some of the stuff we'll be showing you today will actually be being put into production for some pretty cool stuff for the state. Metadata stuff here. The metadata API, I mentioned that there was kind of 2 APIs that are used for sort of doing metadata. Mongo is one of them, and it's called metadata. So we store a lot of different objects in this, and the stream service sort of leverages some of the metadata API for storing information about, you'll learn about projects, instrument information, sites and things like that, as well as recording a lot of provenance of things that take place in the gateway. And so just so you know, a lot of the work that's going on when you're using these APIs is being stored in this metadata. Since we're going to be using actors, I was going to talk just a little bit about workflows and containers within Tapis. If you're not familiar, what is a container? It combines all the dependencies that you would have for your software. So like the operating system, software libraries that your code may depend on, your code, and you can even add data dependencies, and just sort of put all of those things into this one artifact that then you can run in any sort of container runtime that supports the container format that you chose. We usually choose Docker is kind of the most ubiquitous one, but and Singularity is another one, but a lot of Docker containers will run with Singularity, Podman, Kubernetes, that sort of thing. Those are the runtime environments that you can run those in. So why would you use a container? Like I said, it's got everything you essentially need to run your piece of software or your workflow, just kind of in one object. Reproducible. So since you have everything there in that container, every time you make a new instance of your container to run somewhere, it should be the same as the last time you made that instance, as long as it's the same version. And talking about that, you can tag these containers with versions so that you know which version of software you ran as you continue to evolve your code and things like that. So you can have different versions of your containers so that you can go back in time and run something that you developed then. And the other thing is they're very portable, so you can develop them and run them on your desktop. You can run them in the cloud. You can run them on HPC systems. So they're an awesome thing. An example here of a workflow that we containerized here. So there's a mapping workflow for the climate data portal that we threw into a container. Originally, we ran like all these different software for pulling out and acquiring data from different places all over the country, doing some machine learning, gap filling, aggregating, and making maps. So this was all sort of something that was developed on a virtual machine prior, not contained, and it gets a little challenging to manage things as you get more complex. It gets harder to scale, and it gets harder to move this workflow around when it's not containerized. So putting it in a container, which Michael Dodge did a lot of work on, and putting it in Docker and getting it to Docker Hub means now we have this whole workflow in sort of one artifact that we can take and run, or we can decide to split some of this up into separate artifacts and chain them together. But either way, having that artifact, it makes it easier to deploy to cloud services like Jetstream or commercial cloud, or we can even deploy into Tapis with its Actor service, which is sort of a cloud for being able to run these containers. So one of the workflows for doing that is building a container by defining essentially a Docker file. In the case of Docker, is essentially like all the steps that you would do normally on your system to install libraries, packages, and then copying your configuration files and code and stuff. So you can essentially define that as the file, build that, deploy it to a registry that you can download things from. If you make it public, other people can download it from. But basically, we're going to take a container from the Docker Hub registry and register it with Tapis, with the Actor service, and so then it becomes available for us to call from, say, like a Jupyter notebook with tapipy, and that's one of the things that we're going to be doing today. So this was something that we worked on developing for the Hawaii Climate Data Portal project, but we'll be doing some of the top part of this workflow today. Lastly, some of the things that we've used Tapis for is automating. And so trying to take the fact that the Actor Abaco service in Tapis has a cron scheduler so that you can tell an actor to run at a certain time, daily, monthly, hourly, whatever, and it will do that within the Tapis sort of Abaco cloud. In our case, we took that rainfall mapping container, and now it runs every day, fetches inputs using Tapis's files API to pull data from the Climate Data Portal storage system, bring it into the Actor execution environment, fetch data from the data providers to grab rainfall data and climate data and things like that. Go through all of those machine learning, QA/QC, gap filling, interpolation, map generation steps, and then output those maps and intermediate files back to the Climate Data Portal and add annotations so that they become available in the user interface that we use for that, and also available in other APIs that we've written. So thanks for your attention for that part of the presentation. All that work was funded by the Hawaii EPSCoR, EQI project, the Tapis framework grant, and then the cyber training CITRAX thing. So with that, I'm going to hand it over to Jared to kind of get into more of the setup and the hands-on portion.
Okay, so I'm just going to go over the organization of the Strings API. Basically, so the general structure of it is it's broken into 5 hierarchical components to represent physical sensor network. The kind of top level component is projects. So you can define a project in it with various properties. And that's the main storage system for all the sensors and other components of it. You can generate a number of sites within the projects. So to create a site, you would give a project ID that falls under, and a description of the site. So this is a physical location where the instruments and sensors are located. So this has all of its positional data, as well as this description of what it is. And then, so a site can contain multiple instruments, which would be the physical sensors that collect data. So give various properties of the actual instrument itself, including properties of the instrument itself. Then an instrument can keep track of several variables. So this would be what if it's a climatological sensor. So let's say it's keeping track of humidity and air temperature. You could give it those two variables. So a humidity variable, air temperature variable, that fall under instruments. And then finally, there's the actual measurements themselves, which are the variables, the actual values for the variables that the instrument collects registered by a date time. So the time that the instrument collected that value. So we'll go through all of this later on. You'll be able to create your own set of these and your own virtual instrument and create some mock data. But this is the general setup of how it's organized. And then there's Abaco containers, which Sean went over some. These are used for actual triggers. So when your sensor station receives certain data, you can create triggers that cause it to basically kick off a function if the data that receives meets a certain threshold. So we'll also be doing some of that later. And that's so for the event handling. Abaco is what Strings API uses for all of its event handling. So we're going to actually set up a Jupyter notebook that has, it's in the logins. There's a Python wrapper for the Strings API called tapipy. So we're going to set that up using Mana. And then you can go through the notebook, create your own sensor network, mock sensor network, and we'll do some processing and analysis on the station data that you put in. So Michael is going to go over some of the setup for actually launching Jupyter notebooks on Mana, if you aren't familiar with how to do that, as well as how to pull in the notebook that we've created and launch that.
All right. Okay. Mind if I get the screen share? Perfect. Okay. Yeah, so for setting up a Jupyter Notebook server on Mana, it's a pretty easy process. We're just going to want to go to the link here on this site. If you're following on the tutorial webpage, just uhhpc.its.hawaii.edu. It'll bring you to a login. You should have received the credentials for this. And so I'll just give 10, 15 seconds for everybody to log in. All right. So once you log in, you should be brought to this dashboard here. If anybody needs another moment, feel free to type that in. All right. So once you're logged in, you're just going to want to go to Jobs. Is that correct? Oh, sorry, Interactive Apps. Interactive Apps, and then to Jupyter Notebook. And it'll bring you to this little construction part here. We're going to want 2 hours. And in this case, 1 core and 6 gigs of RAM. no need for graphics. We're just going to go straight to launch. All right. From here, it'll just tell us that it's queued. After about 5 to 15 seconds, we should have it running. So once it is running, we're going to go to connect to Jupyter, which will then bring us to the Jupyter home screen here. Now, if we go back to the tutorial here, that's the completion of module 2. Is everybody caught up so far, just on the Jupyter home screen? All right, cool. Okay, moving on to installing the dependencies that we'll need for this workshop's notebook. So, oh, hold up. Okay, I'll just roll back real quick. So I just went to interactive apps, then to Jupyter Notebook. I'll just show what it looks like here. 2 hours, 1 core, and 6 gigs of RAM. And then you'll just launch it from there. Okay, okay. So onto installations. So we're going to want to open up a terminal to start installing Python dependencies using the pip package manager. So starting from the Jupyter interface here, you're going to want to click New and then Terminal. And that'll bring up a new tab with a terminal here. And then you're just going to want to type in this here, which is on the tutorial. Let me swap out that 3. Okay. And we're on that, and you should end up with everything happy. I already have it installed here, so the requirements are satisfied. I'll give everybody a little bit of time to allow the downloads to process. And then feel free to give a thumbs up once you're, or is that one of the, yeah, like a thumbs up when you're all done. I'll just go back to the command here in case anybody needs more time. It's just new terminal and then this right here. All right, anybody need more time? All right. Okay, so moving on to getting the notebook. This is also a pretty simple process. So you just go back into the terminal. And you're just going to want to clone this Git repository here. So feel free to just copy and paste it in. That should just take 5 seconds. Okay.
I'm sorry, could you drop that the installation link into, for some reason I can't seem to find it on the original website that was sent out. Sorry about that. Thank you.
Oh, oops. Okay. Yeah, there it is there. Right. Yeah, so once installations are done, we just clone the notebook, which is now copied here. So once this is done with cloning, we're just going to go back to the home page, and we're going to see now that we have a new folder here. Just going to click it, and then our new notebook from that repository is available right here. So we're just going to click that. And this will bring us to the start of part 4. So yeah. So I'm just gonna run back through, make sure everybody's all ready for part 4, got their dependencies installed. Okay, yeah, I think, let me just go back to the beginning. I think we've got a little bit more time if people need to, yeah, a couple more minutes. Just make sure we're not rushing anybody. Okay. Okay, yeah, no problem. Yeah, we're just getting all set up for part 4. So I can just run by it once again for anybody that's catching up. Yeah, this page sort of goes through it with screenshots. So that's just the page that I'm screen sharing right now that Sean put in the chat. So yeah, our main 2 things right now is we're installing dependencies in Python. So these are just a few, or pretty much just one library. Able to install and bring up the notebook. Okay, was the error this in particular, just the do you trust the system prompt with pip? Okay. Okay.
What is the error that you get?
I got an error message that didn't stop the installation, but it was just like a sort of a message about one of the sub packages and how it might not update in the future. But mine was still able to successfully install itself.
Okay.
Yeah, I got the same one too. That
Yeah.
October 2020 thing that DT just sent in the chat.
Yeah, I think this is a warning and not an actual error.
Okay. Yeah, we can. Yeah, we could do a quick test, I suppose. Once you get to the just to the notebook on part 1, if you just hit Control Enter on the first block, if there are any errors that come out of that, then we may have to address that. But if it loads fine, we should be good. Okay.
Did you get that in the notebook when you ran the imports?
Yes, correct. But it did go through, like it says in 1, so it did happen, like whatever in there did happen, but then this also showed up.
Is that, you mean the pip install when you did that?
And no, this is I'm on exactly the same page as you are. The import get
Running the
pass.
import.
Yeah,
Yeah.
import get pass from date time from blah 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 blah. So it shows up like in 1, so I guess it did go through, but that error also showed up underneath, or warning.
Okay.
I assume the import statement works, but that's just a dependency warning, but I just wanted to let you all know.
Hopefully that won't cause issues down in the notebook.
Yeah, we could try run through the next block and see if it works for everyone.
All right.
So in this next part here where it's asking for username and the password, so everybody should have access this spreadsheet. If you haven't, let me bring it up. Let me paste it in the chat again.
I may have mistyped that. Yeah.
So post got the terminal should be inside of the Jupyter session and not the Mana terminal, just to be clear. So if you have not already, go to this spreadsheet here and just select one of the accounts. There's training 2 through 30. The idea is just to grab one of those. You just mark it as grabbed so that no one else will grab it. And the username and the password are the same. So these are temporary accounts that are just up for today. So actually what's happening here is we're accessing the Tapas services. So that base URL in that cell, that's the tenant in Tapas. So there are different groupings, different tenants. So this is a training one that's just specifically everything that's inside of this, the accounts, the data are all related to training and tutorial things that we do. So we don't put anything in here that we want to hold on to. We wipe out the training tenant frequently for this. We'll have other production tenants. So there's a tac.tapas.io that is a production tenant that uses TAC accounts. And there's a public.tapas.io that also uses TAC accounts. And we will be rolling out a UH tenant here in the next couple of months so that you'll be able to use UH credentials to do the same things.
Okay. So for everybody, feel free to just put a thumbs up reaction if you're into the notebook editor here. Okay. Okay. Yep. Cool. And anybody feel free to virtually like put your hand up if you need a moment to get caught back up, and we can help anybody. Okay. Okay. With that, I'll pass the screen back to Sean and Jared to continue with actually using the notebook. Let me stop my share here. All right.
Okay. So yeah, like Michael said, the first part is just importing packages that Notebook relies on. Second portion, we're actually going to configure the Tapis client object. So use the username and password from the spreadsheet that you claim. Username and password should both be the same. So if that is successful, then when you run this next block, the client.access token, you should get something like this. So does everyone have this? That means that Tapis is successfully configured. Sorry, where's the...
Can you hit the Control+ on yours there, Jared, just to make your screen a little bit bigger?
Oh.
There we go. It's a little easier to read. So one of the things to note, I mentioned that REST idea in the background. So as Jared said, we're making a client. So our client can make calls to the Tapis service. So this is making REST calls whenever we're going to use when we're using this client. This is also using that tapipy Python library that I talked about to be able to interact with Tapis. And then as Jared shows here, this access token. So instead of passing passwords back and forth as we make authenticated requests to the Tapis services, you essentially log in and you get assigned a token. And this token is what we use to send authenticated requests to the Tapis services, so that Tapis knows that this is me, the user, asking for things, but my password and my username are not flying all over the internet. So essentially we get assigned this token and we use this to authenticate, and these tokens expire. So they're good for typically about 4 hours. So that's just one of the security features there.
So if everyone has Tapis configured, we're going to start by creating a project. So this is just initializing some IDs that we're going to use. So we're just using generic names for them. Smart Data Workshop project, site, and instrument, followed by your username, so that they're all unique to each person. So from that, and then we'll create the project object, which has the name of the project, just description. You're free to update the description if you want as well. Owner and PI, which are just going to be you, that is currently active, and then an empty metadata object. You can add additional metadata to the project there if you want. So, and then this, so client is the Tapis object that we created earlier, and then Streams API, and then they'll create the project using the parameters defined in this project object.
So the idea is that this client object that Jared's mentioning has this token stored in it, and so that way we don't have to pass the token in as a variable whenever we make requests. It's just automatically done as part of part of the software.
Yeah, so that's part of the tapipy like Python wrapper for around the streams API. Yep. And then if that's successful, you'll get something similar to this. And that's the project object. We're going to do the same thing for the site. So this is a little bit different. So you can give it the project ID that it falls under. So that's the project that we just created. Then a request body that contains information about the site that we're trying to create. And this is an array. It's also possible to create bulk sites under a single project using one call, but we're only going to create one for this. So yeah, site ID for the name and ID, description, latitude, longitude, and elevation. So this is the location of our fake sensor station. And then empty meta object and same basic thing. We use the create site method with these parameters to generate a site in Canvas. And then they'll print out the site details. And then similar with instruments. So give it project and site that you created. And then we're just going to create a generic instrument. So this is a representation of a physical instrument that's collecting data. And then for variables, we're going to create rainfall and temperature. So this would be basically saying that this sensor station instrument that we created is collecting rainfall data in millimeters and temperature data in degrees Celsius. And yeah, you can add those both by putting both objects in here. And then for measurements, we're going to create a set of just simulated measurements. Yeah, so basically we're just going to take random temperature data between 60 and 9, random rainfall data between 10 and 200, and the current date time. So it's going to run a loop. It's at nanosecond precision, so it can capture the variations between loops. Then it'll just push this data in. We're going to create 100 measurement objects. And yeah, push that. So this will create these measurements, add that to an array, variables array, and it'll send it to the instrument that we created. So this is the set of data that we generated. So I'll pause for a second here and make sure that everyone was able to create their mock sensor station or sensor network with their information. If there are any issues, let me know. This actually isn't supposed to be here.
Yeah, it is. I
Yeah,
added
so-
it so there's some sequential that we'll see as a grouping, and then there's the ones that you have that will make random insertions throughout the year.
Okay, that's fine. Looks like there are any issues. Okay, so we're going to create randomize temperature and rainfall data throughout the year. So basically, this is going to take starting from January 1st, 2022. Going to add a day every time. So this is going to create a new data point for each day, simulating daily sensor station data for temperature and rainfall. And this is creating, basically, it's a little bit more involved than the other one. It's just creating a Gaussian distribution between minimum and maximum rainfall. Based on average temperature and rainfall values and their standard deviation. And again, that's going to create a set of measurements and set of measurement objects and push that into the sensor station using the create measurements function. Okay, so once you have all of the measurements pushed into the station, we can download that data in a CSV format. And then, so this is basically this is using strings data. It's going strings data and requesting all the measurements from January 1st, 2021 through December 30th, 2025 in format of a CSV. So this is all the measurement data that was pushed in that.
We could also, the other format that's supported is JSON. So I talked about that JSON format. So for a lot of, if you're developing software applications and things like that for the web, and you're wanting to pull sensor measurement data out, JSON is a good format for that as well. So.
Then we're going to place that into a pandas data frame. The advantage of pulling it in a CSV format in this case is that we can import it to pandas relatively easily. So this will put into a pandas data frame and display data. So this is the rainfall and temperature data registered by date time in format of of course, it's a truncated pandas data frame because there's a lot of rows. And then this will plot the data that's available in this data frame and save that to SLPNG. So this is the time series output. This is that initial data that we were putting in because that was just randomized data over a large range. So this is over a few nanoseconds under the current date, but the rest of the randomized data is here. This would be more accurate to rainfall and temperature data that you would see by sensor station.
Need to fix the temperature, or I need to fix the axis labels. They're kind of cut off. They're only showing like the hours and not the full date time. But.
Yeah, I think it's just because the time is long and then it's completely sideways instead of at an angle. So. No, it's still too long.
Anyway, we don't need to worry about that.
Okay. So was everyone able to plot sensor station data to image?
some thumbs up. Okay. So just to recap, up to this point, essentially what we've been able to do is you've been able to access the Tapis APIs. In particular, the Streams API, you've been able to essentially create a project, which is sort of a way that you want to group and organize the kind of concept of, deploying physical sensors in the field. So if we were going to call it, say, the Hawaii Mesonet project, and we wanted to say have a project that was say Oahu, and that would be all the stations in Oahu, we would say, I'm going to make a project, we'll call it Mesonet Oahu. That would be my project. And then I'm going to create some sites. So at each different geographical location around Oahu, I would create a site object. And then if there was an instrument station at that site, I would then make an instrument and tie it to that site. And that site's tied to our project. And so the idea is that, there's this hierarchical grouping so that we can, better be able to organize all of these things. And then at each instrument, we're going to measure, as Jared said, temperature and rainfall in these cases. And so those are the variables that we created so that we have information about what are we recording off of the instrument, and then we can, tag that those data as they come in with that metadata information for temperature in degrees Celsius and rainfall and millimeters and things like that. So this is helping us track the provenance of the information that's being recorded off of the instrument that's coming into the API and stored in Streams. And then we've been able to access the data that was pushed in. So we've been able to pull the data out and download it as a CSV and graph it in pandas there. So that's just kind of the recap of what we've been able to do thus far. So Jared, take it away.
So the next thing that we're going to do is create a system for storage in Tapis. So where this ID is, go ahead and change the first part to your user ID, so 22, and then also append your last name. Just make sure that it's unique, because the name storage system is unique. And then for the effective user ID, put in your user ID. So it should be whatever you got from the spreadsheet, same as your Tapis user ID. Then your root directory should be /home/ and then your user ID.
And the host ID there is just hard coded this time. That's the IP address that we have for the Jetstream virtual machine. So that's what the storage system is going to be, that virtual machine that we created up in the Jetstream cloud. So it has the username that you have. There's an account on that machine as well.
Then we're going to add your user credentials to the system that you just created. So this is the Jetstream VM, so the password should just be training. That's the same for everyone. The username is your Tapis username. So and then system ID is the ID that you created here.
And I will note that the normal way, the best practices way to do this is to use SSH keys to register the credentials for a system that you want to be able to access using Tapis. The credentials are stored in a HashiCorp vault, and so they're encrypted, and then they're stored in there, and then they're only accessible to your with your user account, and then you can use this to revoke them at any time. And also the idea of using the SSH keys is that it's really easy to revoke SSH keys on a system that you're using with this. So go ahead, Jared.
So let's do that. The server down there.
I think a few of us are getting a server down error.
Run it the second time. I think sometimes there's a.
Yeah, Yeah, I've now run it like 4 times. And I use the same system ID and username.
Sorry, is that at this portion or so is that for the create user credentials, or is
No,
that
create
separate?
system, the system was created, but then in the add login credentials so Tapas can access the system, that's where I'm getting, looks like me and Aditya are getting the same issue.
Okay, so in this line, and you changed the system ID to the one you created and your username.
I think
Yeah.
it's an issue with accessing the Tapas service. Try and run the files list, Jared, and see if you have an issue. I see some chatter that something happened with one of the pods on Kubernetes.
Oh yeah, I'm getting served that as well.
Yeah. Always during a demo.
Oh, it's, not.
Oh, you know what? Everybody go back up to the top and let's re-authenticate. So it looks like there was some kind of hiccup with the training environment, and so it went. I think maybe it probably dropped all the tokens here. So go ahead and run that cell again and see if that will fix this no authorized issue.
So yeah, that's a second cell in the notebook. Just recreate the authenticate, remaking the client output.
Okay, so that worked for Jared. Now see if you can list files, Jared.
Yeah, it's still not working.
Hold on. Let me make sure Jetstream is actually still up. Make sure they didn't have some kind of weird network outage. What's up? Can you scroll down, Jared, so that I can see what your thing is here? No, or just one of those, I guess. So looks like you can SSH. Create another system, Jared, and just give it a different ID, like 1. And see if it will let you create a system. You change
all of this is
all that can be the same, just has a different ID. Okay, change your ID in the client system credential creation.
And the password for this is just trained, right? Because this is
Correct.
for the judge training.
That's the Jetstream VM, so it's a different password.
Something. This did work the first time.
Yes, yeah, I'm. Let's see. Can you copy that password or copy that error message for me so I can paste it to the folks in TAC? Just put it in the chat.
I sent it slow.
Okay. I need to bring this back up. Okay. Let's move past this and see if we can do part of this exercise. So let's not create an actor. Let's go down to the Discord part. So the actors need to be able to write their files out. So
This is something.
so here, what this is so you're able to write measurements into your instrument, and the data comes in, it flows in. We have an influx database that's kind of behind the scenes. What we want to do is we want to set up some way to evaluate the data as it comes in based off of kind of a basic expression. And so we call this, there's a threshold kind of thing here that's going on. So if you have some values and they are greater than or they're less than something, you want to execute some sort of something else to do some analysis. One of the things that we're going to do is kick off an actor. The actor that we've pre-built for you actually requires that we have a storage system to be able to upload back a piece of something that code is going to execute. But in this case here, what we're going to do is we're going to kick off a message to something like a Discord channel or a Slack channel, or you can use another kind of generic webhook for some other service that you want to pass an alert to that you've exceeded or tripped this threshold in some way. So we're going to create what's called a channel. So everyone subscribes via channels to stuff nowadays. So what you need to do is change the channel ID, because that is unique. You need to add your name to this. So training Discord channel, add your name. So that it's a unique ID. And then the channel name is, it can be whatever you want. The identifier just has to be unique here. This template, if you wanted to do some more complicated stuff in the future for evaluating some of the data, there are Flux scripts that could be written, but to keep it easy, we have a default template that we use that just accepts a single variable type and an operator of greater than or less than and some value that you want for a threshold. So this is a very easy way to work with this. And you can see the conditions that are in there is you define what instrument is this coming from, because instruments have a unique identifier, and then what is the variable, what is the measurement type that we want to evaluate every time it comes in. So in this case, it's going to be rainfall. And so when rainfall exceeds 150 and a measurement comes in that's over 150, What this will do is it will kick off a post this message in the action there. So that action stanza there that has a method. So our method is Discord. It could be Slack, or it could be Webhook, or it could be Actor at this time. But we're going to use Discord. And Jared, do you want to show in Discord how you actually make a webhook URL?
Yeah.
So if everybody is interested, you're going to need to make that bigger, I think. I don't know if you can do plus on there. There you go. So you go to your Discord.
So if you go into server settings and then overview integrations, go to webhooks. You should all have permission to create webhooks here. You can click new webhook and then name it whatever you want. Default name that I gave was Cafe Hook. I'll leave it as that. And then you can copy the webhook URL. And if you should then be able to put that in here, and that will send it to the webhook that you created.
And then that message field down there, you can change that to say something else. It's just really generic since we are using rainfall. I just put it in rainfall, and then there's this notation here with this $ curly brace, r.value curly brace, that will actually pass back the value that triggered the exceeding the threshold in some way. So Jared, if you execute that now, you should have something unique. Or you have
that was fine.
Okay, so now we've registered this, and so this will just continuously run in the background within Tapis streams, and so it's just waiting for data to come through, and it's going to evaluate that rainfall field as it comes in. So there is the next cell down below is how you is set up so that it will write out a value that will trigger exceeding this threshold. So in this case, it was rainfall being 200. So Jared, I don't know if you want to go up above and underneath where we had the alerts.
Real fast, I'm just going to show where I ran that it did trigger that. So I had changed my message. So this was the one that I just ran, and it shows that the value was 200, which is the value that we input there. Sorry, you want me to run the what's data?
No. So scroll down to nope, too far, sorry. So where would the first actor register cell would be? So there's that channel. Sorry, go down a little bit further. We're kind of out of order since things are in a weird state. So listing the alert here that happened. So that client streams alert there. So copy that into the cell, and let's put it in the cell below the Discord cell. Now the other one above that.
Put that just here.
No, new cell, all the way at the bottom. All right, and then what do we assign the channel to? That Discord channel, I think it's Discord channel variable. Yeah, so see Discord channel variable. There's a variable we assign the object to, Discord channel equals.
Yeah.
So let's use that, and let's check. So whenever we whenever one of these channels triggers, there is an object that gets written out that's called an alert.
This doesn't have a
Should have channel ID.
shows it as having channel ID.
Just copy Discord channel to a cell and then do .channel ID.
It's
Okay, that's new, but
there we go. Yeah, Discord channel was wrapped in a tuple, so I access the first element of it, and then that should, there we go. And that shows the full information for the alert that was generated.
right. So this is what happened here. This information contains the ID for the channel that this triggered for. It contains the value that triggered it. It contains the type that this is our Discord, channel, and then it contains like the time and other information that about when this kicked off. And so every time, the threshold gets exceeded, another one of these alert objects gets written to your channel, so you can see the history of that happening. See if they made any progress in getting things back up. Maybe not. Do you want to see if you can run that system thing again and see if it's back up? The files listing, or no, not one. Or your new credentials.
Yeah.
No, still something's had something go down.
Should be authenticated because it is, like token, everything should work because we're able to do the work with registering.
Yeah, we can register an actor. We just won't be able to see the files. Just won't be written out because we aren't able to create the storage system with credentials to be able to upload them from the actor. So it's an unfortunate API that went down.
Okay. So we'll create actor and do all of that stuff. So if you scroll back up to right under where we're having the issues under the list files where it says my actor equals client, but actor is a great actor. So we're going to use that image, which is just a that's going to be a Docker container that Sean created. Then update this with, I guess that won't actually work. Saying that actors has no attribute.
Oh, Yeah, you should be able to make a new cell and do client.actors, and you should be able to autocomplete, and the method should be create actors. Plus the plus sign, escape, and hit the plus sign by the same disk.
Oh, okay.
So you can look at the actual methods that are on here. So client.actors. Sorry, you can tab complete. Tab complete.
Well, let's see.
So just type client.actors and then try and do a tab complete. So tab.
Tab isn't doing it.
Really?
A lot of the tapipy stuff is like, I think it has something to do with how it generates it using the open API spec. Oh, okay. I put that. That's my bad. Sorry.
Okay, so create actor.
Oh, okay. It's not good. Okay, that's weird. It broke the like underscore styling for that. Okay, so that created actor. It's going to do something similar to what we did before, except we're going to create a channel using this actor that we created. This has to be and this will use that ID from the actor that we created. And this will create a threshold for any value greater than 100 under temperature. So now if we create a temperature value of 230, it should generate an alert to that channel that we created because that's over 200. And now if we list the alerts on
So just hit the list the alerts again. Sometimes it takes a couple seconds for
there. Yeah.
to populate.
It was just still processing. Yeah. So and generate the alert from put in, and if we get the value, yeah, that's the value of 30 on temperature.
And so the thing about this is that actor that we registered up above with that channel. So the actor is inside of that actor is this Docker container that contains a bunch of code. So the code that we use to pull data and plot data and save out that plot in test.png, we have very similar code that's inside of that actor. So when this triggers, what it does is a message is passed to our actor in Tapis, telling it with the information for which variable in streams that triggered, what the value was, and what time it was triggered. And so it essentially pulls a window of data out of the streams API within the actor from that information, and then does that plot, saves out a file, and then it was going to upload that file to the system that we were going to create earlier. So this JustStream virtual machine. So that's why in this definition of the actor, there's a system ID and then a path to write files out to for this actor in particular. So I think if you scroll down, Jared, you can actually, when you do this alert, the information that's in there, it says the actor, and then it also has the execution ID. So anytime an actor gets run, there's an execution ID associated with that run. And so we can use that down below. So we can fetch out this alert. So there's a number of alerts. They're sort of in kind of a, a list or an array of alert objects. We can fetch out the latest alert, and we can look at actors, and we can get the execution log for this actor that ran. So I'm guessing it's camel case. So
there we go.
So this is the log of what was outputted to the standard out inside of this. So I outputted there's the access token that it was using. There's the JSON message that got passed in there. So that has all of the information about the streams measurement that was triggered this to run. And then which project ID, site ID, instrument ID to pull data from, what time frame it pulled data, the range it pulled data from. If you scroll down a little bit more, it gives you a printout of the data frame, the pandas frame that it made. And then it's going to error out where it can't, where it couldn't upload. So that last part there is, it wasn't able to upload out its data, but.
And then, yeah, this part would be actually getting that files, but because the system's down.
So yeah, apologies that looks like there's some kind of hiccup with one of the APIs that's making sure that being able to add the auth credentials onto a system is working. So they're working on fixing that. Because I guess as we talk about containers, all these different APIs are actually contained within the containers themselves and are run on a Kubernetes cluster over in the Texas Advanced Compute Center. And so one of the cluster nodes had an issue that had this API on it. And so it's a rare thing, but like they're trying to figure out how to get it back up. So, but anyway, this is hopefully folks have learned some interesting things about the APIs here, and the potential for being able to write out instrument data and track instrument data from sensors that you might have in the field that are smart connected, and being able to add threshold checks and things like that. Some other things we're going to add in the future are dead man checks. So if data is not coming into this system for a certain amount of time, it can issue one of these alerts or Discord or email or something like that as well. And then another thing we're going to be adding is integration into like large computational workflows for running jobs on HPC systems or other cloud systems. So those are some of the other things that we're going to be adding in for workflow integrations into sort of this streaming data as it comes in. So, all right. Well, if there's no other questions, mahalo. Everybody have a great weekend. Appreciate it. So we will we'll see everybody next time.